The Boca National Building Code does not explicitly require water sprinkler fire suppression in a concrete block room containing electrical equipment. However, the requirement may be based on local building codes or specific project requirements. Water is a conductor of electricity, making it extremely dangerous for electrical fires. It can create an arc flash and cause explosions. Consider alternatives to water suppression, such as clean agents. Clean agents are gaseous agents that extinguish fires by replacing oxygen. Examples include FM200, Novik 1230, and Energen. Dry chemical agents are powdered agents that extinguish fires by smothering them. Examples include potassium bicarbonate and sodium bicarbonate. Carbon dioxide gas extinguishes fires by diluting the oxygen concentration in the air. It is recommended to contact the local authority having jurisdiction to verify the requirement for fire suppression. If water suppression is required, consider alternatives such as clean agents, dry chemicals, or carbon dioxide. Consult with a qualified fire protection engineer to determine the most appropriate suppression system for your specific application. As additional considerations, the room should be well ventilated to prevent overheating of equipment. Electrical cables and connections should be properly maintained and inspected regularly to minimize the risk of fire. Personnel should be trained on proper procedures for handling electrical equipment and responding to emergencies. When dealing with fire suppression in electrical rooms, especially those containing high voltage equipment like 4160 volts variable speed drives, it's crucial to understand the risks associated with different types of extinguishing agents. Water, while effective in many fire scenarios, poses a significant hazard in electrical fires due to its conductivity. Using water on electrical equipment can lead to short circuits, arc flashes, and potential explosions, endangering personnel and causing extensive damage. Therefore, alternative fire suppression methods are necessary. Clean agent fire suppression systems are designed to extinguish fires without causing harm to electrical equipment or posing a risk to personnel. These systems use gaseous agents that are electrically non-conductive and leave no residue, making them ideal for protecting sensitive electronic components. Common clean agents include FM200, which is a hydrofluorocarbon HFC compound that suppresses fire by removing heat from the combustion zone. Novik 1230 is another popular clean agent, a fluoroctone that has a low global warming potential and a short atmospheric lifetime, making it environmentally friendly. Energen is a mixture of inert gases such as nitrogen, argon, and carbon dioxide that reduces the oxygen level in the room to a point where combustion cannot be sustained. Dry chemical fire suppression systems utilize powdered agents to smother fires by creating a barrier between the fuel and the oxygen supply. These systems are effective for extinguishing various types of fires, including electrical fires, but they can leave a residue that may require cleanup after use. Common dry chemical agents include potassium bicarbonate, sodium bicarbonate, and monoammonium phosphate. Carbon dioxide, CO2, fire suppression systems extinguish fires by displacing oxygen, effectively suffocating the flames. While CO2 is an effective extinguishing agent, it can be hazardous to personnel in enclosed spaces due to its ability to reduce oxygen levels. Therefore, CO2 systems are typically used in unoccupied areas or with appropriate safety measures in place. When selecting a fire suppression system for an electrical room, it's essential to consider several factors, including the size of the room, the type of equipment present, the potential fire hazards, and the applicable building codes and regulations. It's also important to consult with a qualified fire protection engineer to ensure that the chosen system is appropriate for the specific application and meets all safety requirements. In addition to fire suppression systems, proper ventilation is crucial for preventing overheating of electrical equipment and reducing the risk of fire. Electrical equipment generates heat during operation, and if the heat is not adequately dissipated, it can lead to equipment malfunction, insulation breakdown, and ultimately, fire. Adequate ventilation helps to remove heat from the room, maintaining a safe operating temperature for the equipment. Regular maintenance and inspection of electrical cables and connections are also essential for minimizing the risk of fire. Over time, electrical connections can become loose or corroded, leading to increased resistance and heat generation. Damaged or frayed cables can also pose a fire hazard. Regular inspections can identify potential problems before they escalate into a fire, allowing for timely repairs or replacements. Training personnel on proper procedures for handling electrical equipment and responding to emergencies is another critical aspect of fire safety. Personnel should be familiar with the location and operation of fire suppression equipment, as well as the proper procedures for evacuating the building in the event of a fire. They should also be trained on how to identify potential fire hazards and report them to the appropriate authorities. Fire prevention is the most effective way to protect electrical equipment and personnel from the dangers of fire. By implementing a comprehensive fire safety program that includes fire suppression systems, ventilation, maintenance, inspection, and training, you can significantly reduce the risk of fire and ensure the safety of your facility. When assessing the fire suppression needs for a room containing a 4160 volts variable speed drive, several key aspects must be taken into account. Firstly, the high voltage nature of the equipment presents a unique challenge, as any fire suppression system must be non-conductive to prevent electrical hazards. Secondly, the variable speed drive itself may contain sensitive electronic components that could be damaged by certain extinguishing agents. Thirdly, the room's specific configuration and environmental conditions can influence the choice of fire suppression system. Considering these factors, it is generally recommended to avoid water-based fire suppression systems in such environments. Water is an excellent conductor of electricity and can exacerbate the risks associated with an electrical fire, potentially leading to arc flashes, explosions, and severe injuries. Instead, alternative fire suppression methods that are specifically designed for electrical hazards should be considered. Clean agent fire suppression systems are a popular choice for protecting electrical equipment, as they use non-conductive gases to extinguish fires without causing damage to sensitive components. These systems typically employ agents such as FM200, Novik 1230, or Energen, which are effective at suppressing fires by removing heat or oxygen from the combustion zone. FM200 is a hydrofluorocarbon compound that is widely used in fire suppression systems. It works by absorbing heat from the fire, effectively cooling it down and preventing it from spreading. FM200 is non-conductive, non-corrosive, and leaves no residue, making it safe for use around electrical equipment. Novik 1230 is a fluorocarbon that offers similar fire suppression capabilities to FM200 but with a lower global warming potential. It is also non-conductive, non-corrosive, and leaves no residue, making it an environmentally friendly alternative. Energen is a mixture of inert gases, primarily nitrogen, argon, and carbon dioxide, that reduces the oxygen concentration in the room to a level that cannot sustain combustion. It is a safe and effective fire suppression agent that does not pose a risk to personnel or equipment. Dry chemical fire suppression systems are another option for protecting electrical equipment, but they may not be suitable for all applications. These systems use powdered chemicals such as potassium bicarbonate or sodium bicarbonate to smother fires by creating a barrier between the fuel and the oxygen supply. While dry chemical agents are effective at extinguishing fires, they can leave a residue that may require cleanup after use and could potentially damage sensitive electronic components. Carbon dioxide fire suppression systems are also used in some electrical rooms, but they require careful consideration due to the potential hazards associated with CO2 exposure. CO2 extinguishes fires by displacing oxygen, which can be dangerous for personnel in enclosed spaces. Therefore, CO2 systems are typically used in unoccupied areas or with appropriate safety measures in place, such as personnel training and oxygen monitoring. In addition to selecting the appropriate fire suppression system, it is also important to ensure that the system is properly designed, installed, and maintained. A qualified fire protection engineer should be consulted to assess the specific fire hazards in the room and to design a fire suppression system that meets all applicable codes and standards. The fire suppression system should be installed by a licensed contractor and regularly inspected and maintained to ensure that it is in proper working order. Furthermore, personnel who work in the electrical room should be trained on the proper procedures for responding to a fire, including how to activate the fire suppression system and evacuate the area safely. Regular fire drills should be conducted to ensure that personnel are familiar with the emergency procedures. In summary, protecting a room containing a 4,160 volts variable speed drive from fire requires careful consideration of the electrical hazards and the sensitivity of the equipment. Water-based fire suppression systems should be avoided, and alternative methods such as clean agent systems, dry chemical systems, or carbon dioxide systems should be considered. A qualified fire protection engineer should be consulted to design a fire suppression system that meets all applicable codes and standards, and personnel should be trained on the proper procedures for responding to a fire. Implementing these measures can help to minimize the risk of fire and ensure the safety of personnel and equipment. When you're grappling with fire suppression requirements, especially concerning high voltage equipment like 4,160 volts variable speed drives, VSDs, understanding the specific codes and regulations is paramount. Often, the building officials and code administrators, BOCA, National Building Code, NBC, which is now part of the International Building Code, IC, does not explicitly mandate water sprinkler systems for rooms housing electrical equipment. However, local amendments or specific project requirements can introduce such stipulations. Therefore, verifying with the local authority having jurisdiction, OJ, is the first crucial step. Now, let's address the elephant in the room. Water and electricity simply do not mix. Water is a conductor, and introducing it to an electrical fire, especially one involving high voltage equipment, can create a catastrophic situation. Arc flashes, explosions, and severe electrical shocks become significant risks. So, if a fire suppression system is indeed required, water is absolutely not the answer. Fortunately, there are several effective alternatives designed specifically for electrical fires. Clean agent fire suppression systems are among the most commonly used in these scenarios. These systems utilize non-conductive gases that extinguish fires without leaving residue or damaging sensitive electronic components. Agents like FM200, Novik 1230, and Energen are popular choices. FM200 works by absorbing heat, effectively cooling the fire and preventing its spread. Novik 1230 is similar but boasts a low global warming potential, making it an environmentally conscious option. Energen, a blend of inert gases like nitrogen, argon, and carbon dioxide, reduces the oxygen level to a point where combustion cannot occur. Dry chemical systems, which use powdered agents to smother fires, are another possibility. However, they can leave a residue that might require cleanup and potentially affect sensitive equipment. Common agents include potassium bicarbonate and sodium bicarbonate. Carbon dioxide CO2 systems can also be employed, but they necessitate careful planning due to the asphyxiation risk CO2 poses in enclosed spaces. They are generally reserved for unoccupied areas or require strict safety protocols. Selecting the appropriate system is not a one-size-fits-all decision. It hinges on factors like the room's size, the type of equipment present, the potential fire hazards, and local codes. Consulting with a qualified fire protection engineer is highly recommended. They can assess the specific situation and design a system that meets all safety requirements and effectively protects the equipment. Beyond fire suppression, several additional considerations enhance safety. Proper ventilation is crucial to prevent overheating of the VSD and other electrical components. Overheating can degrade insulation and increase the risk of fire. Regular maintenance and inspections of electrical cables and connections are equally important. Loose or corroded connections can create resistance, leading to heat buildup and potential ignition. A trained workforce is your first line of defense. Personnel should understand how to handle electrical equipment safely, recognize potential hazards, and know how to respond in an emergency, including the location and operation of fire suppression equipment. Regular fire drills can reinforce these procedures. Remember, fire prevention is always the best strategy. A comprehensive fire safety program encompassing suppression systems, ventilation, maintenance, inspections, and training significantly reduces the risk and ensures a safer environment. So, to recap, verify the local fire suppression requirements, avoid water at all costs, explore clean agent, dry chemical, or CO systems, consult with a fire protection engineer, prioritize ventilation and maintenance, and train your personnel thoroughly. By implementing these measures, you can confidently protect your 4160 volts VSD and ensure the safety of your facility.